growth, okay? But because of the fraction, it makes it logistics growth. Which, remember, means that it's going to grow rapidly, but then it's going to level off at some point. Okay, so that's what we're looking at an example of. So it says, on a college campus of 5,000 students, one student returns from vacation with a contagious and long-lasting flu virus. The spread of the virus is modeled by that equation, where y is the total number of students infected after t days. The college will cancel classes when 40% or more of the students are infected. So on the first question, it asks us, how many students are infected after 5 days?
At least one.
What would we do?
Like,
Just plug in 5.
right.
So we would have y equals 5,000
Over.
divided by 1 plus 4,999 times e to the negative 0.8, and I'm plugging in 5 for my time. 5,000, what did you say, and 91? Point what?
560.
Okay, so for us, we would say 5,091 students. Agreed? Were we all okay with how we got that number? T is our time, which in this case is days, so we plug it in, and then you plug it into your calculator. That's it. Now it asks, after how many days will the college cancel classes? So, what do we have to know? We're trying to find days, right? So we're wanting to solve for t.
No. Why?
We're wanting to solve for t.
Yeah. And you want to figure out why.
So what is our y going to have to be? They don't give it to us, but they kind of give it to us. 40%. 40% of what?
5,000.
5,000, which is what? Numbers. So you would multiply 5,000 by 0.4, which gives us 2,000. Are we all okay with that?
Sure.
So we're trying to solve for t, agreed?
Yeah.
Now, our equation looks kind of funky, I agree. But we want to break it down. So we're solving for e to this stuff. So remember, our end goal is to get the e to the stuff by itself. So we can take the natural log. Agreed?
Mm-hmm.
Now, where is that currently located? In the denominator. We don't like that, right? We agree?
Sure.
So we're going to multiply both sides by our denominator in order to get it out of the denominator.
I am a little scared because really, really long math equations are actually kind of fun.
This is one.
Now, notice I have a 2,000 that's being multiplied, so what would we do?
Multiply
You
it
could
by-
distribute it, but you're going to get a really big number there. What could we do instead?
Divide.
Just divide it. Because notice that both of those have 3 zeros. So what are we going to be left with? 5 halves, right? Which is also
2.5.
2.5.
2.5.
Now, it's okay to put it as a decimal there because I'm not rounding. Like, that is the exact decimal. So I'm okay if we put that as a decimal.
Try human calculator.
Now we want to subtract 1.
So 1.5.
And now we're going to get a not so pretty number because we're dividing by
Oh my god.
4,999.
I'm going
And
home.
then do natural log.
But then we want to do the natural log of that. That's going to reduce with our e. So we're just left with the natural log of 1.5 divided by 4,999. Because I had to subtract 1. Because I had 1 plus that stuff. And again, remember, our goal is to get e by itself. So I had to get rid of all the other stuff. So then what's our last step?
Divide by negative.
Correct. So we would have t equals the natural log of 1.5 divided by 4,999. And again, that's all inside of our logarithm. And then we're going to divide that by negative 0.8.
And you get 10.5.
says the college will cancel classes when 40% or more are infected, and it's wanting to know how many days. Okay, so it would be 11 days.
I bet George Washington never had 11 years.
Yeah, you're right.
And so that would be our final answer. And again, remember that here is our graph, and eventually it's gonna level off. Why would it level off?
Because they cancel school.
Well, no, not because they canceled school. How many students do I have?
5,000.
5,000.
So you can't go more than 5.
I
So
can't
one
go more
thousand.
than 5,000, right? Because I can't infect more people than I have. And then also, there might be like 1 or 2 people that never get infected. So you're probably never actually going to reach
You'll reach out.
5,000. Ah!